right, so we've just finished up simplifying, adding, subtracting, multiplying, and dividing rational expressions. Today we're actually going to solve rational equations. So we are going to see an equal sign today when we are solving to get an answer. So our warm-up just has us finding the least common multiple of each pair of fractions. We're looking for the least common denominator, really, for the pair of fractions. So what would be our least common denominator between these two things? Numerically, we would have 15. Algebraically, we would get t squared. Comparing our two denominators here, the least common multiple of the denominators would be just 8. We can do 2 times 4 to get 8 and leave that one 8. Now, when we see these algebraic expressions, we may want to factor them to help us identify a least common denominator. So this one already has a k plus 2, but we would need a k minus 2 as well. So k plus 2 and k minus 2 would be our least common denominator. So today when we're solving, we may get extraneous solutions. So these can be introduced when you multiply both sides of an equation by the same algebraic expression. An extraneous solution is a solution of the derived equation, but not of the original equation. So the long short of it is you need to check to see if these are actual solutions. All right, so steps to solve. Okay, step 1, you have 2 options. You can find a common denominator and multiply everything by the common denominator, which will cancel out your fractions and you'll simplify and solve. Or, when possible, you'll want to cross-multiply. Now, cross-multiplying is when you have a fraction equal to a fraction. You don't have any addition or subtraction going on each side. And you can actually just cross-multiply to get 30 equals 4x and divide by 4, and we would get 15 halves or 7.5. Okay. So you'll notice that some of these are able to be cross-multiplied, and we'll see on the back that some of them are not. So our first one, we notice we have a fraction equal to a fraction, so we will cross-multiply. So we'll multiply diagonally. Now you do want to make sure you distribute. So we'll have 5x squared minus 5 equals, and again, we are distributing the 15 to each of the two terms. We'll get 30x minus 30. Now we need to solve by getting all of our, since this is a quadratic, get all of our terms on one side, and then we'll be able to factor it. So I'm going to subtract 30x and add 30. So I get 5x squared minus 30x, negative 5 plus 30 plus 25. So at that point, I got it set equal to 0. Now I'm going to factor and solve. The first thing you'll always want to do, if possible, is take out your GCF. So we can take out a 5. And that makes this factoring so much easier. We'll get x minus 5 and x minus 1, and actually solve to get your answers. Now this 5 is kind of irrelevant because you'll get 5 equals 0, which it doesn't. Here we'll get x equals 5, and here we'll get x equals 1. Now before I circle my answers, I am going to plug them back in to make sure that they do not get me an extraneous answer. So we would have 5 over 2 times 5 is 10, 10 minus 2 is 8. And on this side we'll get 15 over 25 minus 1, which would be 24. And you can see that 15 24 is reduced to be 5/8. So that works. Now when we test our 1, we will get 5 over 2 times 1 is 2 minus 2 is 0. So right away I can see that this is undefined. I'll get that divide by 0 error. So that's extraneous. My only answer is 5. Okay, next one, the same thing. We can cross multiply because we have a fraction equal to a fraction. Make sure you distribute that -4. Now when we cross multiply here, I'm going to multiply the 3 and 5 together to get 15. Then I'll distribute the 15 to each of these terms. And then, since this is a linear equation, I just need to get my x's on one side and my numbers on the other. So I'll add 4x, and I'll subtract 30. Oops, I shouldn't have boxed my answer until I check it, right? So I get x equals -2. So now let's check it. And I should mention you also can check this in your graphing calculator if you would like to. Mine's closed off right now. But you can store it in for x and you can type it into your graphing calculator. But I'm just going to do this one by hand. So we'd have -4 times 5 over -2 plus 2, which is 0. Well, I'm going to get -4 over 0, and I don't even have to do the rest of the problem. This is going to get me an undefined answer, which means this is extraneous. So I really have no solution to this problem. So that's what my answer is, that there is no solution. And that will happen sometimes. See if you can try the two below on your own. All right, coming back together then, I did cross multiply here and simplify down, getting everything set equal to 0, factoring, getting my two answers. And I'm going to show the check of this one on the graphing calculator so we can see both methods. So I could take my -3, store it in for x, and then I'll test this in my original. So I'll have -2 divided by, now you'll need to add in a set of parentheses around this. So we'll have x squared minus 2. Hit enter and we get a big long decimal. Now I'll do the other side of the expression and see if it's the same big long decimal. So 2 divided by parenthesis, x minus 4. We can see that those are the same values, which means this is a solution. Now we can now take the 2 and store it for x. And then if you want, you can actually press second enter until you recall your previous value. And you'll see that those match. So that is also a solution. Number 4 would be the same thing. If you'd like to try it on your own, go ahead. We'll cross multiply. Again, remembering to distribute. Since this is quadratic, we want to get it set equal to 0. So I'm going to subtract x squared and add 9. And then unfortunately we have no GCF, so this is a harder guess and check factoring problem from chapter 5. So I know this is going to be a 5x and an x. And then my options are either 9 and 1 or 3 and 3. So let's try, 9 and 1 is going to be too big or too small, so let's try 3 and 3. And since they're both going to be the same sign and they need to be negative, we'll put negatives. So this will get me minus 15x minus 3x, which is negative 18. So I did it on the first try. Then we will find our two zeros. So we'll get x equals 3/5. And over here we'll get x equals 3. Oops, don't circle yet. Let's check them out. Now, right off the bat, I can tell this one is extraneous. 3 minus 3 is 0, and I can't have 0 in the denominator. So if you can do a quick check, then it's not as long of a process. So let's store 3/5 for x, and we'll have 1 divided by parenthesis x minus 3. Make sure you group any binomials, and then we'll have 6x divided by x squared minus 9. We get the same weird decimal, so we know that that one checks. Now on the back, we have a couple that cannot be cross-multiplied. Why can they not be cross-multiplied? Because we have two fractions and not just one set equal to another. So for these, we're going to go back and we're going to use the first step of the directions. We're going to find the common denominator and we're going to multiply everything by it. So what this is going to do, in Algebra 1, I call this fraction magic. So we're going to go look at all our denominators, 2x, 5x, and 2. We're going to find the LCD, which will be 10x. And then what we're going to do is we're going to multiply everything by 10x. You need to distribute it to all three pieces. And then fraction magic will take place and we will no longer have fractions. So I'll show the work on the first one. We'll get 10x over 2x minus 20x over 5x equals 10x over 2. Now once you simplify, the magic takes place and we no longer have any fractions. So the x's will divide out to just leave me with 5. The x's will divide out to leave me 20 divided by 5 is just 4. And over here, I can divide to get 5x. Perform these operations. 5 minus 4 is 1. And to solve for x, we'll undo multiplication with division. So we'll get x equals 1/5 or 0.2. For our circle, let's check it. And again, you can do this in your calculator or we can do it by hand. So 1/5 stored in for x. 1 divided by 2x minus 2 divided by 5x. And that equals 0.5, which is 1/2. So it checks. Next one. Also, you cannot cross multiply. Because we do not have one fraction equal to another fraction. We have three things here. So we're going to find our LCD of the denominators. We have x and x plus 1. So the LCD is actually x times x plus 1. It's both of those elements. You may benefit from putting this over a 1 as well. So now we're going to multiply the whole thing by the LCD. X times x plus 1 all over 1. Now on this example, I'm not going to show all of my work. I'm going to cross-reduce mentally. So when I distribute this, the x's would cancel, and I'd be left with 4 times x plus 1. Minus, and when I distribute this to my second, the x plus 1s would divide out to leave me with just 3x. Now don't forget to distribute to the other side. That's one big mistake I see. When I distribute this over here, I'm just going to get x times x plus 1. And then we just need to clean it up. So distribute. And distribute. Combine your like terms. Now, since this is a quadratic, since we see it squared, we know that we're going to have to factor. So we need to get this in standard form. So get it set equal to 0. So let's subtract x and subtract 4. Now the x's will just go away. We're just left with x squared minus 4. That's the difference of squares. That factors down into x minus 2 and x plus 2. So our two answers are 2 and negative 2. And then we would normally go through the process of checking those, but for the video I won't. I will let you know that they both do check. All right, I'd like you to complete the closure on your own. I'll pause the video, and you should too. When you're done, press play and see if you got the answer correct. And here's our answer. So we get negative 11/5 or negative 2.2, which does check out. All right, your homework is 9.6 worksheet 1. It is a front only, and it is in your packet.